Hello and welcome to this first lesson looking at chemical reactions. In today's lesson we're going to be looking at chemical and physical reactions. So if you could write that title in your book as you would do for any other lesson. By the end of this lesson you should be able to give some examples of chemical reactions and physical changes. You should be able to explain what a chemical reaction is, giving some examples. And you should be able to evaluate if an observed change is a physical change or a chemical reaction. So again, if you could write the title Chemical and Physical Reactions in your exercise book, we will make a start. So we're going to start today's lesson with a key term, and as always, key terms in my lessons are written in green. So we're first of all going to look at what a chemical reaction is. So a chemical reaction. Now, a chemical reaction can be defined as the following. It's defined as a change in which atoms are rearranged to create new substances. Are rearranged to create new substances. So a chemical reaction is defined as a change in which atoms are rearranged to create new substances. Now, before the reaction, the atoms are joined together in one particular way, and after the reaction, they are joined together in a different way, which forms a new substance. So we can say, and I'm going to put it in red, we can say that before a chemical reaction, comma, the atoms are joined in one way but are joined differently after the reaction. After the, and we'll just tidy up that the reaction. So if we imagine that we've got one substance being added to another, so we've got substance A being added to substance B. So we've got substance A being added to substance B, which I'll do in orange. So this is substance B. If we add those together, we could theoretically make substance C. And because the substances of this is a chemical reaction, the atoms have been rearranged differently. So we've got substance C, and substance C will consist of lots of orange ones joined to lots of blue ones, which I'll draw the orange ones in a second. So we've gone from having substance A and substance B separate to now having them joined together. We've rearranged the atoms. So because we've got the atoms in a different rearrangement, this is therefore a chemical reaction. So we can say a chemical reaction has taken place as the atoms have been rearranged. That's the worst as ever. As the atoms have been rearranged. Have been rearranged after the reaction. Okay, so we started off with substance A and substance B, and then a chemical reaction has taken place to make substance C, where we've got the molecules, the atoms, have been arranged into a different formation. Therefore, this is a chemical reaction. Now, both elements and compounds can take part in chemical reactions. So we can put in red, because it's an important point, that both elements and compounds take part in chemical reactions. Take part in chemical reactions. Okay? Now, chemical reactions do not tend to be reversible. At the end of the reaction, it's very difficult to get the original substances back. So in a chemical reaction, if you look at our example here, we added substance A and substance B together to get substance C. If this is a chemical reaction, it's very difficult to turn substance C back into substance A and B. So we can say, and first of all, we'll define the word reversible. So I'm going to put it in green because it's a keyword. Reversible. And if I can just quickly look in my notes for a definition of the word reversible so that we have a proper definition rather than one that I make up on the spot. So the word reversible can be defined as a change in which it is possible to get back the original substances, in fact, we'll say full stop. Now, chemical reactions do not tend to be reversible. Okay, it's very hard to get back the substances that you started with. So I'm going to put underneath here that chemical reactions do not tend to be reversible. Full stop. Okay. Now, as well as making new substances, chemical reactions also transfer energy from the reaction to the surroundings. Okay, so I'm going to say the chemical reactions transfer energy to or from the surroundings. Okay, now some examples of chemical reactions I've got on here. The first one we'll put up is the picture of rust. So when iron rusts, it reacts with oxygen to form iron oxide. So the iron inside of a metal will react with oxygen to form iron oxide, which we can call rust or iron hydroxide. Okay. Another example would be when we fry an egg. When we fry an egg, we bind up the proteins found inside the egg to form a new substance which we see as a solid egg, which we eat. Another example, and I'm going to bring this one up because it's on some of the questions that you may have later. This is a picture of a fighter jet, if I make that a bit bigger so that you can see it before I make it smaller. This is a picture of a fighter jet firing off flares. Now, flares are so that the Army and the RAF and the Air Force and whoever else can see what's in the area. Now, these flares contain magnesium, and magnesium glows up very brightly when it's burnt, so it makes it very useful as a flare. Okay, so a chemical reaction is a change in which atoms are rearranged to create new substances. Before a chemical reaction, the atoms are joined in one way, but after the chemical reaction, they are joined differently. For example, you could have substance A and substance B, which once they're reacted together in a chemical reaction, they form substance C, which is joined together differently to how they were before the reaction. Both elements and compounds can take part in chemical reactions. A reversible reaction is a change in which it is possible to get back the original substances. Chemical reactions do not tend to be reversible. They are reversible, but you have to do a lot of things to them to get them back to how they were. Chemical reactions transfer energy to or from the surroundings. Examples of a chemical reaction include the rusting of iron, the frying of an egg, or the use of magnesium in flares. So we can put the subheading now. How do you know if it's a chemical reaction? So how do you know if there is a chemical reaction? Question mark. Okay. Now, in order to know if there is a chemical reaction, you need to be able to make what's known as an observation. Now, an observation is essentially when you use your senses to detect something. So, an observation, which is our next keyword, observation can be defined as information gathered by your senses. Information gathered by your senses. Now, when we say your senses, we mean your sense of taste, touch, smell, sound. So we can put underneath here, senses include taste, touch, smell, hearing, and sight. So you may taste something has happened. You may touch and feel that something has happened. So in order to know if a chemical reaction has taken place, you need to use your senses. You need to make an observation. So we can say that observations allow us to tell if a chemical reaction has taken place. Okay? So there are lots of things you could look out for a chemical reaction, but some of them could certainly include the following. So the sort, we can put the sort of things you may observe in a chemical reaction include dot dot. You might see flames, so seeing flames or sparks. You might see a gas given off, seeing gas given off. You might be able to have a sweet smell, so you might smell something sweet. At the same time, you might smell something horrible. So you might smell, I don't know, fart. So smell something horrible. You might be able to feel that something is getting warmer. So you might be able to feel, it says felt, not feel. You feel, what's going on with my spelling? Feel a substance get hotter. The flip side to that is sometimes you might feel a substance get colder. Feel a substance get colder. You might be able to hear a loud fizz. So you might be able to hear fizzing. But at the same time, you might hear a loud bang. Okay? You might even be able to see a colour change. So, seeing a colour change. These are just some of the ways that you might be able to observe that a chemical reaction has taken place. So, how do you know if there is a chemical reaction? You make an observation, which is information gathered by your senses, which include your taste, touch, smell, hearing, sight. Observations allow us to tell if a chemical reaction has taken place. The sort of things you may observe in a chemical reaction include seeing flames or sparks, seeing a gas given off, smelling something sweet or smelling something horrible, feel a substance get hotter, feel a substance get colder, hear a fizzing or hear a loud bang. You might even see a colour change. These are all indications that a chemical reaction has taken place. So, how are chemical reactions useful? So, how are chemical reactions useful? Okay. Now, we can make lots of useful substances with chemical reactions. So, lots of useful substances are made by chemical reactions. They can include the following. So, medicines are made using chemical reactions. So, medicines. An example of this would be paracetamol, is made through chemical reactions. Another example of substances made through chemical reactions include fabrics. So fabrics such as polyester, so I'll just put e.g. polyester is made using a chemical reaction, and building materials such as cement is made using chemical reactions. So building materials. So such as cement is made via a chemical reaction. At the same time, the chemical reactions we said earlier transfer energy to the environment, and we can use this energy to do things. For example, we can burn petrol, which will make vehicles move. If we burn coal or gas, which can heat water, which can generate steam to generate electricity. So we can put, and I'm going to put in regs, it's important, we can say that chemical reactions also transfer energy. Okay? Which, I'll put comma, which we can use in various processes. Okay? We can use the energy transferred in various processes. We can say, e.g., water can be heated via or from chemical reactions or from heat generated in chemical reactions to make steam which turns a turbine to generate electricity. Okay. So not only is it useful to make substances from chemical reactions, but we can also use the energy that is released in other processes. Okay. Some chemical reactions are not useful. Things like rusting. Okay, rusting is something you don't want. And certain chemical reactions can also make food rot. So we can just say in red again, 'cause it's important, some chemical reactions are not useful, such as rusting. Rusting is not very useful to us. Now, some reactions are not chemical reactions. Some reactions are what we call physical changes. Okay? So our next key term is the term physical change. A physical change. Now, a physical change is different from a chemical reaction. Okay? A physical change can be defined as a change that is reversible, a change that is reversible in which new substances are not made, in which new substances are not made. Full stop. Example of these would include something going from a liquid to a gas or just a change of state. Or it may also include dissolving. Okay? So we can put underneath here, e.g., changes in state, or dissolving. An example would be such as water becoming ice. Okay? So we can just say underneath here that water can be frozen into ice, then melted back into water. Comma. This is an example of a physical change. This is an example of a physical change. The reason this is a physical change is because it's reversible. We can get the water back. And at the same time, we're not making any new substances. All we're doing is freezing the water. We're not turning water into something else. We're just changing its state so that we can get it back to where we had it previously. So chemical reactions are useful because they can make substances such as medicines, fabrics, and building materials. Chemical reactions transfer energy, which we can use in various processes. For example, water can be heated from heat generated in chemical reactions to make steam, which turns a turbine to generate electricity. Some chemical reactions are not useful, however. This includes rusting or food beginning to rot. A physical change is a change that is reversible, in which new substances are not made. This is the opposite of a chemical reaction. So examples of this would include changes in state or dissolving. Water can be frozen into ice and then melted back into water. Therefore, this is an example of a physical change. So, you should now be able to give me some examples of chemical reactions and physical changes. You should be able to explain what a chemical reaction is, giving examples, and you should be able to tell me if an observed change is a physical change or a chemical reaction. Should you have any questions about this lesson, please contact me via the usual means and I will get back to you as soon as I can. If not, I will see you in the next lesson. Thank you very much.